is true.
I'm trying to think, because that is right. There was a question in the homework that was just kind of a trick question that was similar to that, where the answer was um, at least two of the means are different. So if we have three, it was saying at least two are different, and that was the trick. Honestly, with ANOVA, the null hypothesis is that they're all true, and then the alternate hypothesis is that at least one of them is different. So we can have like 17 different samples, so 17 different groups, and as long as one of them is different from the other 16, then we reject the null hypothesis.
Okay. Okay, so for this question, it says that at least one mean is different, so it would be true, right?
Yes, so in the ANOVA hypothesis, we reject the null when there's sufficient evidence that at least one mean is different from the other. So we could have, in our group of 17 samples, we could have 16 are the same and one is different, we reject the null. All 17 are different, we reject the null. Any combination between those two, we reject the null. The only time we would not reject the null is if all 17 are the same.
Okay. Okay, cool. So true, and then 4 is... So the data in each group are normally distributed, and the variances are equal in each group.
And actually the first one also.
Oh.
If you look at the reading...
Oh, because they can't be negative.
Yeah, they're saying with an F distribution, all values will always be positive. But that's only with the F distribution. The other distributions are different.
Oh, yeah, that's right.
And how are we defining variances are equal? What's the threshold that we're gauging it by?
Oh, you look at all the variances, and if the largest variance is like it was like 4 times if it was like if the smallest variance how was it worded? So pretty much you times the smallest variance by 4, and if it's larger than the largest variance, then they're not equal.
Yeah, a little dyslexic
pretty much
there.
Am I getting a dyslexia?
I think you understand what you're saying. You just said the wrong conclusion.
Okay. So we want the variances to be equal. And
yes.
So okay, so let me see. In my notes, I said, I was reading from my notes, so it's way better. If the largest variance is less than or equal to 4 times the smallest variance, then we will conclude that the variances are equal.
Yes. So yeah. So the fact that the variances have to be equal, that doesn't mean they all have to be exactly the same.
Mm-hmm.
And I actually think, I know there's a reason why they chose the rule 4. But it seems that like if one variance is 4 times bigger than the other, it seems like it's pretty big, but apparently it's not. So our definition of equal is just what you said. You take the smallest, times it by 4. If all the variances are between the smallest variance and the smallest variance times 4, so almost like a confidence interval, if all the variances fall within that range, then we're considering our variances to be equal. Or at least not different enough to affect our test in any way.
Okay.
But I would just go by the way that you wrote it in your notes. You actually defined that perfectly.
Okay. 5. We do the QQ plot for ANOVA, I guess. That was the new thing they talked about.
Okay. And this is actually, question 6 is just what we were talking about a second ago.
So it'd be the largest variance is less than 4 times the smallest variance.
Exactly.
Okay. Ooh.
What's the quick way to do this?
Would it be 4? I guess I am.
Simple. I'm trying to think.
Yeah, I didn't think it was that simple either, but it says right here if there are 3 samples, there are 3 pairs. So I'm like, I mean, if there's 4 samples, is there 4 pairs? But I think it's more than that, maybe.
You can think of it as each number is not going to be paired with itself. So you have group 1 pairing with group 2, and there's 1 pair, group 3, and group 4. So there's going to be 3 groups for each of the 4, so there should be 12.
Or 6.
Probably 6. I think I doubled it for some reason.
I think I just wrote it out. I think it's 6.
Okay, let me just a second. Oh, you're totally right. Because order doesn't matter.
Mm-hmm.
So 1 and 2 is the same as 2 and 1.
Mm-hmm.
So is my answer divided by 2, which is 6.
Ooh.
About soccer shoes. Now you need to highlight, open up another document that actually has the ANOVA stuff.
Yeah, I kept all the Excel sheets up for the practice exam, and I didn't want to change it without.
I'll pull it up real quick. Quantitative inference. There it is. ANOVA. Okay. What's the question actually asking? Soccer shoes. Okay. I guess it's just pull up the two spreadsheets and just start copy pasting.
Yeah. Did you include socks?
Yes.
Okay, let's see here. So what is the minimum variance? It would be 27.208.
Let me double check. Yeah, 2017-08. The maximum.
53.1058.
The test, yes, goes 53. Is less than even double 27. So we're good. QQ clouds. QQ plots are like the one thing that I've not figured out how to do in Excel. They keep popping
Yeah.
up. Have you been able to figure it out?
I'm looking back at the homework right now to find the instructions on how to do it. Okay, found it. Oh yeah, so we had to pull up the that other Excel sheet.
Oh, it requires a different Excel sheet.
Yeah, so you know how you pull up the quantitative um the Excel sheet we've been using? Um the other Excel sheet, so the quantitative descriptive statistics is the one that we want.
Oh, okay.
Sometimes it doesn't pull up though. Computer.
They should have just like saved these documents like months ago, literally.
Yeah.
Every time, I'm just like, oh, let's go pull it up.
Gosh, I have so many tabs up right now. It's not coming up. Okay. Okay. Did you find the Excel sheet?
Yeah.
Okay. So the first variable does not look normal to me at all. Is that
Yeah, it's all over the place.
all over the place? So, um, I mean, do we need to check the other ones? Can we just say false since this one looks crazy?
Technically, we should check the other ones, but since we already know that it's no good, might
Yeah.
as well just put false.
Okay. Okay, next one. If you perform.
Yeah, I'm sure if you're like a certified statistician as a part of the American Association of Statisticians, they'd ream you if you didn't.
Mhm.
The students in this class, I'm like, whatever. I'm like, they're just having us plug it into an Excel spreadsheet anyway.
Yeah.
Which I will observe the p-value is 0.08. Remove the SOX data and do it again. Okay, what did you get for the p-value when you removed SOX?
Um, with socks, it was 0.093
Really?
with the socks.
That's what I got when I took SOX off.
Oh, really?
Yeah, when I did all 6 variables, it was 0.081. And then I
Huh.
just deleted that column. And when I deleted that column, it jumped up to 0.309.
That's weird. Huh. Let's see what happens if I delete that. So when I delete this sixth column, I get 0.384. You got different answers?
Yeah, like I said, when I had all 6 columns, it was 0.81.
Mm-hmm.
In fact, the question even says if you perform the ANOVA test, you will observe the p-value is 0.081. And then it
That's
says to the SOX. Did you happen to copy paste the same column twice or something?
maybe. Let me check. Okay. I think I found it. Okay, so let's see. Without the socks, I got 0.309.
Perfect, that's what I got.
Okay, okay.
This lesson seriously is, how do you read a spreadsheet? Next
Statistic.
question. Test statistic is the F statistic. Is the p-value to the right or left? They're like, oh, there's the F, p-value is to the right.
Yeah, I was gonna say it's always to the right. Okay.
Honestly, this class has been interesting, but these last 2 lessons, I kind of feel are insulting our intelligence.
Yeah, a little bit.
But I'm not the only one who feels that way. Okay. Hot dog nutrition. food plots for each of them. Wait, are we doing QQ? Oh, just for the calories.
So are we doing it for both, for all three different kinds of hot dogs?
Yeah, but just the calories, not the sodium.
Okay, so I got a pretty random, well, there is a little bit of glue kind no.
Let's see. That one I got doesn't follow the line at all. It's pretty much like forms a trapezoid almost.
Yeah, it looks, I mean, there's like a little bit of grouping by point 0.8. I don't know if you see that on, but yeah, no, it's pretty random.
Just double check me and poultry since we only got 3 groups this time. Okay. Oh, weird. Super weird.
What?
If you put in the numbers for meat and
Huh.
then include the very last number for beef, 132, it becomes like a serious straight line. But if
Really?
you, yes, but if you delete that 132, it's just as random as the last one.
Huh.
I did not understand how QQ plots work. That's weird. Let's just check poultry just for the heck of it. Oh, that's our problem.
What?
That's why it got weird. Okay. Um, step 1, paste data into column A. Step 2, sort column A from lowest to highest. We haven't been doing that second part.
Oh, sort column A from. Wait, how do you sort column A from lowest to highest?
It should be. Where did it?
Oh, I think there is a function or something that you can just press.
Yeah, it is just a simple function. I'm just trying to remember it. I did this just the other day.
Yeah.
There we go.
Oh, I
And
found
at
it.
the top, yeah, if you go data and then sort.
Yeah. That's funny, we found it at the same time. Okay, so that looks a lot less
Yeah.
random. Yep, okay.
Okay, so poultry looks pretty good. Let's redo meat. I'll redo meat if you want to redo beef.
Oh, I did all three of them at
Oh, you
once.
already did all 3 of them?
Yeah. Oh, like at once. I just copied and pasted all of them.
And formatted it?
Uh-huh. I can show you. Oh, I literally just did the whole thing.
Oh, I don't think you're supposed to do that.
Oh, really?
Yeah, because I don't think, unless you're seeing like a different QQ plot page that I'm seeing, it looks like you can only test for one variable at a time. So I think we have to go beef, meat, and then poultry. Because if you just do all of them together, then it doesn't know which numbers belong to which variable.
Okay, that makes sense. Okay, so which one did you want me to do?
Do beef, I'll do meat. Because yeah, the poultry one checks out. Okay, meat, not perfect, but I'd say it's close enough.
I don't know why it's being weird. Yeah, this one looks good. Okay, so I guess probably go back to that one question. So, let's see this one first.
And it's also asking about the variance,
So would
so
it be
gotta plug them into the other sheet.
I think we have to go to the bank because I was on the phone.
thanks.
But
So do we, so we're doing ANOVA, right? And so are we dividing? Oh, we're just looking at calories, aren't we?
Yeah.
Yeah, I'm sorry. I answered my own question. Never mind.
Okay. Okay, so the QQs look normal. Variance varies between 508 and 636, so there's definitely not a fourfold difference there.
Mhm.
So I would say the assumption has been met.
Sweet.
Assumptions have been met. It's safe to assume variances are equal. What's that last one say? Okay, so the answer should be the first one.
Okay.
Okay, let's go back up to that one question about suckers. And now my computer doesn't want to open the file. Okay, there we go.
Okay, so
Okay, so we have to check the QQs one by one. So if you want to start with A, how many are there?
6.
Okay, if you want to do A, B, and C, I'll do socks, E, and D.
Okay. So this one, A looks good, except that there's 1 point random, not on the line.
I'm getting that with E2. It's like way below.
Yeah.
But I think that's just an outlier. So I think what they're looking for is, if you remember a few lessons ago, they talked about curving at the beginning or end and
Uh,
making this shape. So I think just an outlier, as long as the rest of the curve looks fairly straight, is fine.
okay.
At least I'm hoping.
Hmm. B looks pretty out there.
How out there?
Here, I'm gonna show you. If that's okay with you. Mhm. So this one's B. I mean, it's kind of out there.
Yeah, you got them in numerical order, right?
Yeah.
Yeah, looking at that, the fact that there's three vertical, then a gap, then three vertical, and it continues is really weird. So I say we keep our answer of that one, of just saying that it's not normally distributed.
Yeah. Okay, so we're on 15 now.
So the NOVA test for calories. For number 2 and 51. F is 16.074, and there's a super small p value. Okay, so what's our conclusion here?
So let's see. We have small. We have insufficient evidence. Oh, okay, wait. We have sufficient evidence that we have sufficient evidence to claim that all three hot dog types have the same mean number of calories.
Okay, what's the null hypothesis here when we're doing ANOVAs?
Let's see. Um, it doesn't give us a null hypothesis.
Not in this question, because the null for ANOVAs are always the same. Do you remember what that is?
Yes. No. Wait.
So this is something I think I'll talk up on the homework. So you'll see that before, then there'll be a good test review. But the different null hypotheses that we have when, depending on what type of test we're running. So the null hypothesis of just a normal thing, just like a one sample sigma known, our null hypothesis is that mu is equal to sigma. So we're saying our average is equal to the population average. When you do a one sample sigma unknown, so we're estimating with the standard deviation, it's still mean is equal to mu. So we're still saying our null hypothesis is that our sample mean is equal to the population mean. When you're doing two different groups, then your hypothesis becomes mu mean one is equal to mean two. Actually, no, I said that wrong. When we're dealing with two, we look at the difference between the two, right?
Mm-hmm.
And so the hypothesis becomes D is equal, so D, the difference between the two means,
Mm-hmm.
D bar is equal to 0, which basically means that the two means are the same since we're minusing one from the other, right?
Yeah.
And then the null hypothesis for ANOVA is that they are all equal. So whether in this case it's 3 hot dogs or in the previous case where it's 6 different types of footwear, the null hypothesis is that the mean for all of them are going to be equal.
Okay, that makes okay. So hmm. Okay, so would it be we do not have sufficient evidence to reject the claim that all three hot dog types have the same mean number of calories?
Well, what's our p-value and what's our level of significance?
So our p-value is 0.
And
And
our
then
alpha?
oh, 0.05. And then, oh.
So if the p-value is smaller than alpha, what do we do to the null?
Oh, we reject the null. Okay, I was looking at the F.
No problem. F is the test statistic, so
Yeah.
F is equivalent to the t-score or the
Mhm.
z-score. But since we're doing an ANOVA, it's an F score.
Okay, so we reject the null. So we have sufficient evidence.
We talked about this at the just at the beginning. See if you remember what the answer is.
Okay, final answer. We have sufficient evidence to claim that at least one of the hot dog types has a different mean number of calories than another type.
Exactly.
Okay.
So
That took me 3 tries. It's fine. Oh man.
the annoying thing is an ANOVA is so much work and it tells you so little. Like we throw it in there and it doesn't even say that like all 3 hot dogs are different. It just says we're pretty sure that one of the hot dogs is different. At least one of the hot dogs is different from the other 2, but it doesn't even tell you which hot dog. So then you end up having to do those pair T scores, against it. So basically, the only thing the ANOVA does is it tells you, okay, well, you can start doing some 2-sample T scores because you have evidence that at least one of them is different. So it's a lot of work for very little payoff.
Yeah.
But it can save you some time if there's like 16 things and you're like, well, there's no difference between any of the 16. There's no point in checking them one by one.
Yeah.
Okay, QQ scores for sodium.
So the assumption has been met. Yeah. So the assumption.
Wait, you already got the QQs done? Or I should probably read the question first. Oh, yep, I just straight went to doing the QQ. Yep, the poultry does look a little weird, starting to form an S.
So would it be it is assumptions were not met, but it's safe to assume each group comes from a normally distributed population. We cannot assume that the variances are equal.
What can we assume? Because we know that one group, the poultry, does not have a normal distribution.
Oh.
That's what the QQ tells us.
Okay, it would be the other way around.
So we can have one, or we can have three combinations. One thing wrong, the other thing wrong, or both things wrong. So
So we know that they're not normally distributed, but we do know that, let's see, the variances are similar, correct? Yes.
Yes, yeah, 7,000 versus 10,000. That's definitely not 4 times larger.
Yeah.
So we can say they're not at least one of the groups is not normally distributed. It's not safe to assume each group.
But the variances are equal.
But the variances are equal.
Cool.
Possible problem for the QQ, you decide to use a nova anyway. For sodium this time.
Okay.
Okay, so what did you get for the p-value?
P-value, I got 0.179.
Perfect, that's what I got. We have a significance value of 0.5. What do we do?
So the p-value is higher, so we fail to reject the null. So we do not have sufficient evidence to reject the claim that all 3 hot dog types have the same mean sodium levels.
Well, actually, think about that. We have the null hypothesis is that they are all the same, and we are failing to reject the null hypothesis. So they switched the wording around on you a little bit on this one.
Yeah. There's sufficient evidence to claim that all three hot dogs. Okay, sorry. So we have sufficient evidence to claim that all three hot dog types have the same mean sodium levels.
Exactly.
Okay. Cool. I can submit this one. Okay, so we got 3 wrong. So we got number 4. We got partial credit on number 4.
Okay, partial credit on number 4, we missed. 11, which was just a true or false, so we can just switch that. And then question 18. That's okay. So
Yes.
we got the correct p-value, which is the p-value is 1.79, which is greater than our alpha, which means we fail to reject the null hypothesis. The null hypothesis is that they're all the same. That's weird. I wonder if there's a fluke in that question.
Yeah.
The other two, we just switched from true to false, or whichever one that was.
Yeah.
And then, let's see. Sample means are all positive. I actually think that one on question 4 isn't necessary, because I think it's the, what? Sample means. Check the book real quick, see what it says exactly. F distribution. The values, oh, that's the problem. I read that wrong. The values of F are never negative, so we will never have a negative F score. But the means can be negative.
Okay, I see what you're saying.
Yeah, it just turns out the example that they gave showed all positive scores, so that threw me off. Okay, so that one's simple enough. Just uncheck that one. And then the other question, which one was it? 11, just changed from false to true. But then that last question, I'm trying to figure out.
Yeah.
Conclusion can you draw about the mean sodium? Level of significance of 0.05 with a p-value that is larger than that. So with a large p-value, we fail to reject the null hypothesis. The null hypothesis is that the sodium levels are the same in all 3 groups. How did they word that we do not have sufficient? We do not have sufficient evidence. Oh, those crafty jerks.
What happened? What did they do?
Answer two, you're totally right. We do not have sufficient evidence to reject the claim that all three hot dog types have the same medium. So what that's saying is that we don't have sufficient evidence to reject the null hypothesis. In other words, we are failing to reject the null hypothesis.
Oh my heck.
They worded that trickily. Okay, my phone's asleep. I need to go walk around for a second.
Okay.
So change those and I'll be back in a minute and let me know.
Okay, and I will pull up, I will end this one and then bring up a new Google thing so I can send it on two different things. So
okay, perfect. Yeah, I just need to go wake my foot up. So give me
yep. Okay, cool. See you in a sec.